Nearly 200 earthquakes were recorded in Yellowstone National Park in the past 2 weeks.
Yellowstone National Park, a natural wonder, conceals a seismic enigma that is now emerging. A multitude of earthquakes have shaken the park, triggering heightened vigilance among scientists. Is this a precursor to a catastrophic eruption predicted by experts? Or is there something even more enigmatic unfolding beneath the park's geysers and hot springs? Join us as we explore the recent seismic activities, decipher their implications for Yellowstone, and perhaps for the entire world. A remarkable phenomenon is unfolding, and you won't want to miss the discoveries made by scientists. Before we delve into the recent seismic events, let's set the stage by understanding the significance of Yellowstone National Park. Established on March 1, 1872, by President Ulysses S. Grant, Yellowstone is not only the first national park in the United States, but also the world's inaugural of its kind. Spanning over 2.2 million acres across Wyoming, Montana, and Idaho, it is a vast expanse of wilderness housing geysers, hot springs, and diverse wildlife, including grizzly bears, wolves, and herds of bison and elk. However, beneath this tranquil facade lies a fact that is sometimes overlooked. Yellowstone is not merely a park, it is a colossal volcanic caldera, one of the most extensive active volcanic systems globally. This caldera is a part of the larger Yellowstone Volcano Observatory, which includes renowned geysers like Old Faithful and the Grand Prismatic Spring. As a supervolcano, its eruptions have the potential to be thousands of times more powerful than typical volcanic eruptions. The caldera itself is a colossal crater, formed during the last of 3 super eruptions over the past 2.1 million years. The most recent major eruption occurred approximately 640,000 years ago, creating the Lava Creek Tuff and forming the Yellowstone caldera as we know it today. This eruption was so colossal that it ejected over 240 cubic miles of rock, ash, and volcanic gases into the atmosphere, causing a global temperature drop and affecting ecosystems worldwide. The ashfall from such an eruption could bury cities and farmlands, leading to catastrophic consequences for agriculture and infrastructure. The release of sulfur aerosols could induce a volcanic winter, cooling the planet and affecting weather patterns for years. Recent studies have unveiled a remarkable revelation. Yellowstone harbors not just one, but 2 magma chambers. The first chamber, discovered in the 1980s, resides about 10 kilometers below the surface, containing roughly 10,000 cubic kilometers of molten material. Deeper still, between 20 and 50 kilometers below the surface, lies a second magma chamber, 4.5 times larger. Together, these chambers possess enough molten rock to fill the Grand Canyon nearly 14 times over. This discovery does not increase the likelihood of an eruption, but it means that the shallow chamber can be continually replenished, providing a constant energy source for the park's geothermal features. In the heart of America's first national park, a seismic spectacle recently unfolded, causing concern among scientists and observers alike. Over just 12 hours, the northern part of Yellowstone Lake experienced a series of tremors that garnered significant attention. The sequence commenced on March 28 with a seemingly minor magnitude 0.7 earthquake, but it marked the beginning of an extraordinary seismic swarm. Within half a day, at least 60 earthquakes, ranging from magnitude 0.1 to 3.7, were recorded, including 2 above magnitude 3.0, with the strongest being a magnitude 3.7. These seismic activities were closely monitored by the University of Utah seismograph stations and the Yellowstone Volcano Observatory. Although earthquakes in Yellowstone are not unusual, accounting for around 50% of the seismic activity in the Intermountain West region, this particular sequence has reignited discussions and fears of the potential big one within the park. The mere mention of a Yellowstone eruption sends shivers down the spine of those familiar with the region's geological power. It would be an unprecedented event, causing catastrophic destruction in the park's vicinity. Lava flows, pyroclastic surges, and ash fall would obliterate everything in their path. The picturesque landscapes, rich biodiversity, and iconic geysers would succumb to the eruption's fury. Moreover, the human toll would be immense. The park and its surroundings host millions of tourists annually, and towns and communities in the vicinity would face severe risks. One of the most alarming aspects of a Yellowstone eruption is the widespread ashfall. A major eruption could eject thousands of cubic kilometers of ash, blanketing vast North American areas. This ash could reach as far as Missouri and Texas, burying areas closer to Yellowstone under several meters of ash. Additionally, the release of volcanic gases and aerosols would profoundly impact global climate, potentially causing a volcanic winter that disrupts weather patterns and agricultural yields worldwide. The geological complexity of Yellowstone must guide our approach to risk management and mitigation in the face of a potential eruption. However, the question lingers: is the supervolcano exhibiting signs of awakening, or are these tremors reminders of Earth's enduring power and unpredictability? To grasp the situation, we must delve into Yellowstone's geological intricacies. The park rests atop a hotspot, a molten rock plume rising from the Earth's mantle. This hotspot fuels the park's geothermal features and is responsible for regional volcanic activity. Recent seismic activity near the eastern edge of the Yellowstone caldera, close to the site of the last major eruption, has prompted speculation about its significance. Seismologists and geologists meticulously analyze data, seeking patterns and clues that might indicate a shift in the volcanic system's behavior. While the University of Utah seismograph stations and the Yellowstone Volcano Observatory reassure the public that recent seismicity does not signify an imminent eruption, it is important to note that the park's geothermal features, such as geysers and hot springs, are not just tourist attractions, but also indicators of intense geological activity beneath the surface. Hydrothermal explosions are a manifestation of this activity, occurring when superheated water trapped below the surface rapidly converts to steam, causing violent eruptions. Smaller hydrothermal explosions resembling unexpectedly large or uncharacteristic geyser events occur almost annually in Yellowstone and could pose hazards to those nearby. Landslides are another geological threat in the region, exacerbated by the unstable terrain, weathering, and seismic activity. These landslides can block roads and trails, isolate parts of the park, and endanger hikers and motorists. One of the most significant seismic events in Yellowstone's history was the Hebgen Lake earthquake. With a magnitude of 7.5, it remains the largest earthquake recorded in the area. The quake triggered massive landslides, one of which dammed the Madison River, creating Quake Lake. The landslide traveled at approximately 100 miles per hour, containing around 80 million tons of rock, soil, and debris. Roads, bridges, buildings, and infrastructure were severely damaged or destroyed, not only near the epicenter, but also in more distant locations. The earthquake also impacted Yellowstone's geothermal features, altering geyser eruption intervals and causing changes in behavior. Yellowstone's diverse landscapes provide a sanctuary for a wide range of plant and animal species. Recently, however, unusual wildlife encounters have been reported, particularly with bison. Incidents involving bison, including a recent goring and a tragic bear encounter, have raised questions about a potential link between wildlife behavior and recent seismic activity. Some experts believe that animals, particularly those with deep ties to the region, may be sensing shifts in underground magma chambers or perceiving vibrations and chemical changes in the environment beyond human perception. This phenomenon is not entirely new, as there have been documented cases of animals exhibiting unusual behavior before earthquakes. In Yellowstone, the connection between wildlife behavior and seismic data is being explored, as animals, rivers, geysers, and earthquakes all share interconnected patterns yet to be fully understood. Given the potential threat of an earthquake or volcanic eruption in this geologically active region, authorities are leaving no stone unturned in their efforts to comprehend, monitor, and mitigate these risks. The Yellowstone Volcano Observatory and its partners have devised a comprehensive monitoring plan encompassing backbone monitoring and hydrothermal monitoring. Backbone monitoring involves enhancing the existing region-wide surveillance network to provide real-time data on seismic activities, ground deformation, and geological phenomena. Hydrothermal monitoring focuses on tracking activity in Yellowstone's thermal and geyser basins, measuring temperature, pressure, water chemistry, and other parameters to detect unusual changes signaling potential geological events. The University of Wyoming, alongside scientific agencies like the U.S. Geological Survey and the National Park Service is actively participating in this monitoring endeavor, underscoring the significance of understanding and mitigating geological hazards in the Yellowstone Plateau region. Yellowstone National Park, a treasure trove of natural wonders, conceals beneath its serene surface a volatile and enigmatic geological marvel. Recent seismic activities have brought this phenomenon to the forefront of scientific scrutiny. While the public's imagination may be captivated by the prospect of a catastrophic eruption, science reminds us that the Earth's processes are complex and ever-evolving. As we continue to explore the mysteries of Yellowstone, we are confronted with the awe-inspiring power of nature, which has shaped the park's landscapes and behaviors over millennia. While the recent seismic swarm raises concerns and questions, it also serves as a reminder of the importance of understanding and respecting the Earth's geological processes. Yellowstone National Park remains a living laboratory, offering valuable insights into the dynamic and interconnected nature of our planet. In this ongoing story of geological wonder and scientific inquiry, we must remain vigilant and prepared, not only to protect this unique ecosystem, but also to safeguard the communities and ecosystems beyond its borders. What do you think the future holds for Yellowstone National Park, considering the recent seismic activity and the potential implications for both the park and the world? Engage with us by leaving a comment, subscribing to our channel, and clicking the notification bell for regular updates. Keep watching, stay inspired, and get ready for more exciting discoveries. See you in our next episode.